So we have learned different transformation techniques, right? So that has been discussed in order to interact with the objects that is present in the screen, sample image or object is considered, and we have found a midpoint of a line. Hello everyone, I welcome you all to the second session of Unit 2, and Unit 2 is all about understanding the fundamentals in depth about computer graphics. So the subject is computer graphics and multimedia. Let me tell you, this is the updated syllabus with respect to SEP of Mysuru University. Over here, my name is Deepa Kutnikar. I'm working as an assistant professor on the Department of Computer Science, Vidhyaashram, Temple of Excellence, Mysore. So over here, this is the content that we have discussed in our previous session, that is in session 1 of Unit 2, where we will be understanding bit in depth about composition, transformations, and the matrix representation, etc. And let's move forward and see what is the agenda of today's session. In today's session, we will be discussing and understanding various techniques regarding 2D viewing of an object and an image. So let's begin our session. Now, before starting with various 2D techniques, first let's understand what is 2D viewing. So it is just a general viewing that we do in our mobile phones. We will see our images or the photos, right? Yes, that is considered as a 2D viewing. Now, let's understand what is the definition of this 2D viewing. 2D viewing is just an conversion of an object from world coordinate to the screen coordinate. With respect to images, what happens is we see in a world format, right? But if you want to do any operations or any changes with respect to that image or an object, it should be in terms of coordinates, right? So that is why a normal image will be converted into the screen coordinate, and this technique is called as what? It is none other than considered as a 2D viewing. Now let's see an example where a normal image is considered. So this is our local normal image, and for this normal image, we are applying object transformation. So we have learned different transformation techniques, right? So that has been discussed in our session 1 of this unit itself. You can go back and check what is the various transformations that are available with respect to 2D viewing. So we will apply any one out of those, and the result we get is the world coordinate image. Okay. Now for this, we will again apply the viewing transformation. Over here, under viewing transformation, again the image will be set to the frame. So that is considered as viewing coordinates. Now it will be normalized in order to separate the workstation area with a complete coordinate area that is available. So that is the normalization effect, and as a result we can see over here the coordinate is being fixed and it can be considered as a normalized device coordinate. Up next is a workstation transformation. So yes, each and every step has a transformation. So according to our requirement, we are converting an object from a world coordinate to what? Yes, to the screen coordinate. So finally, we get a object that is converted from world coordinate to the screen coordinate. So these are the basic simple steps that has been followed in a real-time example. All right, now let's move forward with next two techniques, that is zooming and panning. So this is a type of 2D image viewing technique, correct? Now let's understand what is zooming. Yes, it is none other than we will change the magnification of an image or an object. So if we do zoom in, what happens? The object will appear more larger and we can observe the small objects even in a good visibility way, correct? That is with respect to zoom in. What happens in zoom out? In zoom out, the complete information can be seen if it is a large information and you are not able to see the complete information in that small screen. If you just zoom out, you can see the complete information that is available, right? So that is the basic zoom in and zoom out that are the different types that we consider under zooming operation. Now let's understand the panning. Panning is nothing but shifting the viewing area. So now if we consider a image that is present in this portion of image, if you want to see it in a more clearer way, then you can shift the seeing angle, right? So yes, that is about the panning. What is panning? It just shifts the viewing area, and zooming, it helps in magnifying a image. Now let's see over here, we have a zooming operation. So we can see a zoom in which is happening, and we can also do the zoom out, correct? By our two fingers on a touch screen, we can do zoom in as well as zoom out, correct? So these are the two different types, and panning is just shifting the viewing area of a image or a object is considered as panning. The next topic is pointing as well as positioning techniques. Now we know that a basic pointing device is none other than a simple mouse, correct? With respect to mouse, we know that it is helping us to point a icon on the screen, isn't it? Also, the mouse will help us in positioning that image or the object, isn't it? So that's why we will be learning and understanding the pointing as well as positioning technique. So it again starts from our 2D viewing pipeline, where a world coordinate will be converted into screen coordinate, and this conversion will also supports to place or point an object efficiently in the screen coordinate. Isn't it? Won't you feel that for any animation or designing a CAD diagram, we need a exact X and Y positions. If it is exact, then we can expect a efficient output. Okay, so that's why we have to consider a pointing as well as positioning of a image or a object too. Let's see what are the different examples. Yes, mouse cursor, then a touch input as well as a stylus device is also an example of our pointing or positioning devices. So let's see a pointing image and let's understand how it works. Yes, definitely we know that, but let's recall it one more time. So over here, how to use the mouse. In order to interact with the objects that is present in a screen, what do? We move the cursor on that object. Now, how is it done? It's by mouse movement, right? And the mouse click is released or it is depressed in order to stop at that point. So, this is the basic thing that we did discuss. Alright, let's move with the next topic, that is none other than a simple rubber band technique. Very, very easy, and we have seen this. So now the next technique is a rubber band technique. So this rubber band technique is also being utilized by a mouse, and now today we will understand like what exactly is that action for which we call it as a rubber band technique. So you might have seen while working in paint, we start from a point, okay? So let's consider this is my starting point in the paint and I need to draw a line. So a line will start from here and the end point will not be fixed. So it will be moving. The cursor at this point will be moving. Have you observed that? Yes. If I want a straight sleeping line, then I can drop it out here. If I want a slant line, okay, let it continue at that point. And in order to make it end, I'll release the mouse there. So the movement of one point fixed and the other point varying is considered as a rubber band technique. Now let's see like what are the different steps involved in order to observe this rubber band technique. So the first thing is there will be an object or an initial display on our screen. Next, for that initial display, we will draw a line with the mouse in the XOR mode and we will fix the first and our second point. Next, the mouse is moved to the new position after drawing a line. Next, we can observe that a original line is redrawn with the same XOR mode. Thus, we can finally see the image with a line drawn in a XOR mode. So this is a rubber band technique. And remember, whenever it is asked, please draw a diagram with the initial display at least and with a new line being drawn with a first and second points. The next operation that can be expected after zooming and panning is none other than dragging. So if you want to move an object from one position to another position, then the technique we use is considered as dragging. Thus, we can say that dragging moves an object interactively using a pointing device. So this is a simple image where we can see that a block inside an image is considered and a pointer is trying to drag that object or a part of image, right? So this is a dragging. The next operation is clipping operation. Now we know clipping in the sense cutting something, right? Yes, we do the same over here. But what do we cut is the outside portion of the object that is not visible in the screen is considered as clipping. Thus, we can say that clipping is responsible for removing objects that is present in outside of the viewing region. Thus, we can say that clipping removes portions of objects outside the viewing region. So now this is a object, like completely you can see two more mountain that is pending to be shown in this frame, correct? So now what happens is, as my viewing region is this much and the rest of the portion that is available is unwanted. Why it is unwanted? Because it depends. It might be not useful, or we can say that it can't be dragged inside our visible regions. There might be a lot of reasons. Thus, we can say that only the viewing portion image will be retained and rest of the portion images that are available will be trimmed off or cut. So this criteria is considered as clipping. Now in clipping, we have various types like point clipping, line clipping, polygon clipping. Here, the first portion we can consider it as a window where all the extra unwanted areas of objects are available. So we can say that it is a window. Now with respect to that window, the starting point is considered as xw min, in the sense x coordinate with respect to window starting point, correct? So for starting point we can call it as a minimum. Next, xw max, x coordinate with respect to maximum portion of that window. Similarly, yw min, y in the sense y coordinate, w goes for window minimum point. Next, with respect to maximum point, yw max. In the same way, next, if you see the clipped image, then we get a good nice image only inside that display part or in the viewing portion, and that is considered as a viewport. What is it called as? A viewport. Now with respect to viewport, again we have minimum and maximum value with respect to x and y coordinates. So it is x v min, in the sense v in the sense viewport, x viewport minimum, x viewport maximum. So similarly, y viewport minimum and y viewport maximum. So these are the points. So we are converting an object that is present in a window to a simple viewport and making it clear to the observer. And what is the technique that we have followed? It is none other than a clipping operation. Now let's see what is a point clipping. Absolutely, as the name itself says, only a point will be clipped off. But that point should be visible or it should be present in the clipping area. If it is present in the window area or the visible area, then it cannot be clipped. If and only if it is present in the unwanted areas, then that will be clipped off, and that is considered as point clipping. So we can see here we have various points. So this is my viewport. Okay, what is this? This is the viewport. And apart from this portion, we have so many points, isn't it? What are those? P7, P4, P2, P10, P8. So these are our clipping window, the points present in the clipping window. So we are supposed to clip those points, and the resulting is this portion. All right. So this is a simple point clipping. We can also fix a range for that, that is with respect to Wx min to max with respect to x coordinate. Similarly, with respect to y coordinate, if a point is within that limits like Wy min to Wy max, then the point will be verified, it will not be clipped, or else it will be clipped off. The next type of clipping is line clipping. Always we can't say a single point will be there inside an image, right? So we have to go with clipping most of the portion of a image. So that is considered as a line clipping. Thus we can say that line clipping determines the visible portion of a line. For example, so this is the image, or we can consider this as a window. So in this window image, you can see a line with point P2 and P1 are present, and a line is available. Now, this extra portion of line is not at all required for us. It will not be visible, and we can't do any operation with it because it is not coming inside a viewport. That's why we can clip it off, and we can retain only the portion that is visible. Thus, after line clipping, we can expect it to be in this form, that is P1 and P2 in the viewport. Alright, so this is line clipping. Now, as this line clipping is very efficient compared to point clipping, we have two more types with respect to line clipping, where first one is our Cohen-Sutherland line clipping. Second one we have midpoint subdivision line clipping that we'll see next to this. First, let's understand what is this Cohen-Sutherland line clipping. This is also a type of line clipping algorithm, and what happens here is it uses the region codes to efficiently clip the unwanted portion of the lines. Now let's see what are the steps or the idea behind this algorithm. Initially, we will subdivide the window and we apply various 4-bit codes. Okay, we apply 4-bit codes for each and every portion. Then we apply or perform the trivial accept or reject test. In the sense, it will verify whether that portion of the image is to be considered or to be rejected. Alright, now we know that we will be subdividing the portion with zeros and ones, right? Now, what is the importance of that zeros and ones? Let's see one by one. If our leftmost bit is high or 1, it means that the endpoint is above the top edge of the window. Alright? Endpoint is above the top edge of the window. Next, from left, if the second bit is set to high, then it means that the endpoint is below the bottom edge of the window. Next, third bit. If the third bit is set to high, then the endpoint is right of the right edge of the window. Alright, with respect to fourth bit, if it is set to high, fourth bit from left is set to high, then it is considered that the endpoint is left of the left edge of the window. So, no need to worry. If you just read it twice, you will easily understand. It starts from leftmost bit and it goes towards the rightmost bit, only 4 bits. So, it is like if a bit goes high, then first top, next one bottom, next one right, and next one is left. So, in this way, the endpoints are assigned. Alright. So, this is a Cohen-Sutherland line clipping. Let's move with the next second type of line clipping algorithm, which is midpoint subdivision line clipping. As the name itself says, here the complete portion of a window is subdivided, or we will divide in order to find the midpoint. Thus, we can say that under this midpoint subdivision, the line will be recursively keep on dividing on a image until a visible segments are found. Now let's see the steps that is followed under this. First, we are supposed to find the midpoint of that object. Then test the visibility, like is a object or an image is visible properly or not. If it is visible, okay, we can stop there. But if it is not visible, we can go with continuing the same, finding midpoint, subdividing, again finding whether the portion is visible or not. So in this way, the steps will follow. So over here, there is a example image, or an object is considered, and we have found a midpoint of a line. And next we will fetch whether the part is visible or not. If it is visible, yes, we can stop there and we can go with clipping the rest of the part. If it is not visible, again we have to go and verify like which is the midpoint, and then again test the visibility of that object. So this is the complete step that has been followed in order to test the algorithm. So this was all about today's session. Thank you.